It's a pleasure to be here presenting to you a couple of years since my first webinar, and so it's should be getting good at this, presenting to a screen at the dining room table. I should start by noting that Peter is a collaborator in this work, and so if there are any difficult questions, I will be asking Peter as the chair to take those questions on my behalf. So this paper, New Index Number Methods in Consumer Price Statistics, what's this all about? Well, first, some background. Peter and Martin O'Connell, I should have mentioned Martin, who's now was at IFS and is now at the University of Wisconsin. We were engaged through ESCoE to review the ONS's plans for using multilateral index methods in the CPI when transactions level data are available. By transactions level data, I mean data such as electronic point of sales data or otherwise known as scanner data. So the report will be made public shortly once clearance is received from the data provider. I understand just today we've got that clearance, and the paper will be forthcoming shortly in the ESCoE working paper series. Should start by thanking the ONS team. We very much work collaboratively with them, particularly Sanjeev and Helen. Also the ONS advisory panel on consumer price statistics. Thank them for their feedback and discussions. Should acknowledge the R package, index number R, by Graham White of the Reserve Bank of Australia. This programming of this package is something he does in his spare time, and it really is an excellent package which makes things very easy, very fast, very efficient programming. And I encourage anyone interested in working on index numbers with scanner data to look at this index number R package. Also, this work has benefited from discussions and collaborations with Erwin Dewert, Jan de Haan, and my former PhD student, Shui Zhang, over the years. But of course, none of them are responsible for any errors, etc., in our paper. So this work looks at multilateral index numbers because that is what the ONS is considering implementing in the Consumer Price Index. So why multilateral indexes? If you've heard of them before, it's likely, and you don't work in time series contexts, you would have encountered them in an area like international comparisons, comparing country with country, prices and incomes across countries. So this is where they were traditionally used. How did they come to be suggested for use in the context of scanner data and consumer price indexes? Well, basically the issue is that chaining of indexes is desirable. That is, not going from comparing today's prices with prices in 1472, but if we can, the previous month's prices and have a month-to-month price index, for example. And we want to chain and link all those month-to-month comparisons up. And the reason for doing that is so we see market developments, because every month products enter and products exit. This is product churn. And we don't want the basket to get out of date, because if we're still using a 1472 basket, there wouldn't be much in common with today's actual consumption patterns. But chaining with transaction level data, like supermarket scanner data, can lead to massive chain drift. So here's a little example of analgesics, painkillers from Dominique's supermarket data. And you see the Spears and Parsh indexes. They're commonly used indexes by national statistical offices. And you see that they have quite explosive behaviors. So there's the Spears. They're very quickly growing by more than 250%. And you see that the Parsh is going down in the other direction. So very explosive. We've got some indexes which are known as superlative indexes, the Turnquist and Fischer. They're kind of in there. You can't see them too clearly, and it's because the Spears and Pasch scaled explosiveness of them is so dramatic. There's also something called a GEX index here. That's the black line. That's a multilateral method. And basically what's happening here is this: we want to try and control this explosive behavior called chain drift. And we can do that using multilateral indexes like the GEX multilateral method. Okay, so in this context, multilateral indexes were introduced for the purpose of controlling chain drift. So the GEX index in the previous figure, it's a multilateral method, so known as a GEX-Fischer index. It's calculated over the full sample of data, which by definition does not suffer from this chain drift bias problem. In other words, it satisfies the weak multi-period identity test, or an axiom that ensures that it doesn't suffer from chain drift bias. So deviations from this index, the black line, then indicate chain drift through deviating from the chain drift-free index. So note how the chain drift bias is especially dramatic for indexes commonly used by NSIs, the Spears and Pasch indexes. So you see the problem is that if national statistical offices just use the irregular indexes with this scanner data, you can, and they want a chain to keep the baskets up to date, then you can get really dramatic results. Basically, standard index number theory breaks down in this context, and you can get explosive indexes. So introduce multilateral indexes which can control for that chain drift bias. But CPIs, they're non-revisable. And the thing about multilateral indexes is they have to be calculated over, say, a set of countries over a set of periods. You add another country, you add another period, and you need to, it affects all the comparisons that you've made, not only in the new period or with the new country, but all previous comparisons as well. So that can result in a rewriting of history. Okay, so it's just the way these multilateral indexes work. Now, with CPIs, non-revisable typically, we can't go around rewriting history. That seems to be undesirable. So then we've got to work out a way of calculating a multilateral index over a window and then expanding or extending that window to extend the series. So if we come up with a method for extending the series, then we reintroduce some sort of chain drift. But it's not explosive like the chain drift that you get from standard index numbers. Okay, so that's why multilateral methods have proven to be quite popular in the case of transaction level data. So where did this idea come from? For those familiar with the literature, there's lots of papers now on using multilateral index numbers. A lot of national statistical institutes are looking at adopting these methods in their CPIs. Where did it come from? Well, in all humility, it came from this paper, Vancic, Dewart, and Fox. Vancic was my PhD student at UNSW, and this work came out of her PhD thesis. So what this paper did was it introduced the idea of multilateral indexes to control chain drift using the GEX and time product dummy multilateral methods, and using splicing of rolling windows for extending the indexes. And so these three components were introduced in this paper, and that is where most of the research in this literature has gone since, and looking at these, which multilateral index to use, and splicing rolling windows for extending, and how large those windows should be. Okay, so how did we come about to do this work? Well, I was actually asked by the Australian Bureau of Statistics to discuss a paper at the Methodology Advisory Committee, and that using scanner data, and that led to a collaboration through the Australian Research Council grant, 2003 to 2005, and then a subsequent grant, 2006 to 8 inclusive, which also included the Central Bureau of Statistics, or Statistics Netherlands. And these grants managed to fund a lot of workshops in Sydney and a lot of collaboration with the ABS and Statistics Netherlands, including exchanges. And out of a result of this, we produced a lot of research, learned from each other, and that led to this paper, which has created this literature on multilateral indexes. I note here a key name, Jan de Haan. His work and our engagement with him was very important for the development of this work that we did. And Jan has been a major player in the scanner data area before us and still. Okay, and we think this is because I'm giving an ESCoE talk, and ESCoE has such a close relationship with the ONS, I thought it worth pointing this out, that this is an example of a positive outcome from NSI engagement with academics. So from those humble beginnings of getting these grants and reading early work by Marshall Reinsdorf and trying to work things out, now these multilateral methods that we suggested in Ivancic, DeWitt, and Fox, they've been implemented in multiple countries and other countries coming soon, apparently. Okay, so there's still ongoing research into the performance of alternative multilateral indexes, splicing techniques, and window lengths for the rolling windows methodology. Okay, so that's a bit of background. So our report, what do we do in our report or our paper? So we discuss and evaluate the properties of different multilateral index numbers. We use UK Kantar data. This is like home scan data. It's over 2013 to 2019 for about 52 product categories. We use the index number R package by Graham White to empirically quantify the difference between different price indices across many product categories. And we do this assessment of these different aspects of implementation of these methods. So index number choice, splicing method choice, and the window length choice. And we also illustrate some empirical determinants of chain drift using this UK data. So what do the data look like? Well, we've got 30,000 households over this period, and we've got a whole range of different products here. And this is total, or the share of total spending over the full sample period. And it goes from up the top here, rather surprisingly, from my perspective, chilled ready meals. They've got the biggest total spending share of these products. And down the bottom here, we've got canned pasta products. I wouldn't have expected that. But anyway, there's lots of different types of products in here. But frozen potato products and beer and lager, toilet tissues, etc. So quite a range of different products are included, or product categories are included in the data. So that's all background. Now we get to the introduction. So just reviewing this again. So availability of scanner data, it potentially allows for the use of many millions of observations on prices and quantities to be used in price index construction. And so we get a lot of micro detail, and we're able to capture changes in consumer behavior more readily this way than if we have to rely on periodic surveys, for example, to get expenditure share weights. But how to calculate these things? Because if we use fixed-based indices, well, the base becomes unrepresentative quite quickly due to product churn. If we chain bilateral indexes like the low index or Spears, Fischer, Turnquist, can lead to explosive indexes or chain drift. So the solution is multilateral indexes that satisfy, it's actually a weak version of the multi-period identity axiom. And that can be explained as follows. So if the prices and quantities so we say we've got 3 periods, and then in the 4th period, the prices and quantities, all the prices and quantities in period 4 are identical to those in period 1, then the following should hold when the index is a chain. So this is the capital P is a price index, and that goes from 1 to 2, and then this one goes from 2 to 3, and then this one goes from 3 to 4, except period 4, we don't have a 4 here. We instead have a 1 because the prices and quantities are the same in that period. Now, so effectively, by chaining this way, we're going from period 1 to period 1, and so the prices haven't changed between the periods, and so we should get back to 1. Now, that doesn't necessarily hold for bilateral index numbers, but it will hold for multilateral index numbers if prices and quantities are the same in period 1 and period 4. So that's the weak multi-period identity axiom. Okay, different types of multilateral indexes. So there's various options. So first is the GEX family of indexes. So the first one there is with the Fischer Index. So they're all similar in the sense that they're taking a geometric mean of comparison. So basically the idea is you take each observation in turn as the base and you calculate all bilateral comparisons between all periods, and then you take an average over those, and the average is a geometric mean. Then you can have different versions of this by varying the bilateral index number that's used to do the comparison, period on period comparisons in there. So the original one, Gini, etc. Method has the Fischer Index, but you could have the Turnquist Index in here as well. And this is what Caves, Christensen, Dewart suggested in the quantity or productivity context back in 1982, and recently Inkler and Dewart expressed it in the prices context. So the GEX Turnquist, we're calling the Caves, Christensen, Dewart, Inkler Index to recognize their contributions. But it's basically GEX Turnquist, and that's what agencies like the ABS call it, but we're calling it CCDI here. And there's also the Walsh Index you can put in there. That's another superlative index. So these are all superlative bilateral indexes, the Fischer, Turnquist, Walsh. We're just performing a transformation on them, if you like, to make them multilateral indexes. Now, there's also the Gary-Khamis Index, and you can think of that perhaps as a quality-adjusted unit value index. It was popular in the multilateral comparisons literature, comparing between countries, incomes and prices. It went out of favor because it became known that its theoretical properties weren't so good, but it seems to have made a comeback, surprisingly, in the prices literature with scanner data. So there are other methods like the weighted time product dummy method, etc. But these are the main ones we're going to be focusing on here. So we've got this linking problem. Okay, so we mentioned that we can construct these. Indexes over a window, and they'll satisfy the multi-period identity test. But then if we want to expand the window, get another period's data, we've got to try and update the original window because just adding the period in it can change all the previous relativities. So one solution is this, having a rolling window approach suggested by Vantage, Dewar, and Fox, and then you link on a period, right? You link the original window to the new window. So it rolls forward one period, and then you do a linking in. Okay, so you need an overlapping period, S. You use that to extend literature. Well, which period should you use? Because there are multiple overlapping periods. So what we did in Vantage, Dewar, and Fox was just say, well, let's just take the last common period between the old window and the new one, and we'll use that to update. An alternative approach is the window splice, and that is using the first overlapping period, which is period 2 if you start at period 1, roll forward a period, and then first overlapping period is too. Another alternative is to take some period in the middle of the window, and you link them up there, and it was suggested by Jan de Haan. Well, which should you choose? Well, Biwott and Fox suggested, well, why do we have to choose? Why not take a geometric mean over all those options? So we get a, we're not dependent on any particular period, and we can avoid the context of linking on an unusual period. Okay, so it's kind of seen as we see it as kind of a safer option so we avoid the possibility of having a link on a peculiar period. Okay, so you take the geometric mean over all those results from all those potential choices. There's a fixed base expanding window. You chain through a base month, so your window actually grows. And I must confess, I'm not sure why you'd want to do that unless you're required to by some legislation, but that's also a method which has been suggested. Recently, Keza has proposed this method of splicing on the published series, so I thought I'd take a minute to discuss this type of approach. So it's the same as before, but splice on the published series, not the previously calculated window. So let's say you've got series A here, this orange series first up, and you've got 4 periods. Then you get series B, and you've got an additional period, right? So the window rolls forward. So the window size is still the same, it just rolls forward. And if you've taken here in the published series, the first 4 from series A, but now you want to get this 5th observation here. Well, you want to try and link series A with series B, and you can do that in multiple places. So let's say you use the window splice, then it would be linking on that period there, and then you work out the growth factor between the windows and get the relativities between them, and then you get blue T5 there. Okay, so let's say we get a series C and it rolls forward again. Well, how do we get this blue T6? Well, if we use the standard window splice, what we do to get the blue T6 is we take this green T6, we divide it by green T3. So that's the growth between green T3 and green T6. And then we divide it by the growth between yellow T3 and yellow T5, as we're doing there. And then times by blue T5, all right? That's how we update that. So if we were to do a window splice on the published series, we forget about the yellow series. All we care about is linking on this top one here, the published series. And so you take blue T3 and multiply it by the growth between green T3 and green T6. Okay, so you're kind of jumping up there and not linking on the most recent adjacent window. And apparently it's asserted that benefit of doing this is that if you do a sort of year-on-year approach, the year-on-year index of the published series is the same as the year-on-year index of the new window. So just some observations on this. It seems to prioritize year-on-year changes, but often interest is in monthly indexes, so month-on-month changes, and, for example, monetary policy. So a central bank may not be too interested in claims that we get year-on-year right, but well, in between we don't really know. Also, if you're going to prioritize year-on-year changes, well, we don't need multilateral indexes. We can do that with any index. A fixed-base Laspers can be used to update the published series and keep the year-on-year growth rate in the published series the same as the new index. I don't see what this has to do with multilateral indexes. And also updating using splicing factors from adjacent windows seems more appropriate, as the product coverage is likely to be more similar between adjacent windows rather than windows which can get quite far apart. It's called the product churn. Wonder what you're comparing. Okay, so other problems of splicing. So it allows the index to be updated without altering the series that has been published, but it reintroduces chain drift. The extent of chain drift for different index number methods, extension methods, and window lengths is an empirical question, and that's what we look at in our study. We note that there are lots of transitory products, Easter eggs, Christmas cakes. New products appear, disappear. Multilateral indexes tend to downweight seasonal products in month-to-month price comparisons, and that's because in many periods the goods are not there. So one solution is to impute prices of the goods with zero quantities, and a problem with that is that Gary-Khamis, GK, and Walsh indexes are invariant to imputation. So goods with zero quantity do not contribute to the index. So even if you impute the price because the quantity is still zero, it has no effect on the index. So if you're only interested in using inflation-adjusted carry-forward prices, then okay, no problem. But if you want to do, say, hedonic imputation for the missing prices, then that is problematic. You can do all the hedonic imputation you like, it won't change your index if you're using Gary-Khamis or Walsh. Okay, so started out by saying that we were engaged to do some work because of the ONS considering which index method they should use in their CPI when using scanner data. And they published a framework to rank indexes, and that framework weights properties of different indexes alongside other considerations like ease of explanation, computation, etc. And the ranking slightly favors Gary-Khamis with this fixed base extension method. Okay, ONS framework weights. Okay, how did they come up with these? Well, they're informed by consultation with stakeholders, but any such consultation is not based in theory, it's still subjective. And it's easy to show that small changes can lead, of those weights can lead to a re-ranking of the methods. The Gary-Khamis or the FBME gets allocated points for ease of understanding plus international use, but the Gex-Turnquist or CCDI with the mean splice is also used internationally, for example, by the Australian Bureau of Statistics. And the CCDI, its relative ease of understanding is usually regarded as it's good. It's one of its strengths. Because it's like, it turns out mathematically, it's like comparing all observations to an average period, which is very easy to explain relative to an index like the Gary-Khamis. Okay. And some in the weighting method, the framework, the fact that Gary-Khamis index is an additive method is viewed positively. That's an additive method means that the corresponding quantity index can be easily decomposed. You just sort of add up the quantities. But the Gary-Khamis price index itself is not a simple weighted sum. Weights change with prices, and decompositions are available for CCDI. And if you're interested in decompositions, I can recommend the Webster, Tano, Mordi paper in the Journal of Official Statistics. So sort of preempting our conclusions here, the Gary-Khamis is found to be relatively sensitive to the extension method chosen. That's the method we're updating it, updating the original window, and the link period. So that those findings are consistent with other findings in the literature, by example, Claude Lambouré and Van Loon and Roels. And Gary Kamas, as we noted, is invariant to price imputation, which is problematic for NSIs wanting to use hedonic imputation methods, for example. So empirically and theoretical considerations lead us to favour the CCDI index, X-Turnquist, with the mean splice and a 25-month rolling window. So some results. So these are, just for comparison, how these indexes all compare. Are they all just give the same result and we don't need to worry about it, or is there a difference? So these box plots show differences from the CCDI index in percentage points. We could have chosen any of these as the base one, but we chose the CCDI. So here's the Gex-Fischer. So the only difference between Gex-Fischer and CCDI is that the Fischer index is used as the bilateral index rather than the Turnquist index in the Gex transformation. Similarly, Gex-Walsh, it's just we use the Walsh index rather than Fischer or Turnquist. And then Gary Kamas, and we also look at a Gex transformation of an unweighted elementary index, Jevons index, which we haven't mentioned yet and probably won't mention again in this talk, but it is in our paper. Okay, so what do we make of this? Well, it's, we know that Fischer and Turnquist from the bilateral context, they're usually pretty similar, but we do notice an outlier there. But it's quite similar for most, that means very tightly packed into quartile range. Gex-Walsh, the same. Gary Kamas gets a bit more spread out. So there's some differences between Gary Kamas and the Gex-based indexes. What does chain drift look like? Well, here's chain drift on using some chocolate data. So this is the CCDI index with the mean splice as an example. So the top yellow line here, this is the one with no splicing. So what's been done here is the CCDI index has been constructed on the whole period's data. So this index satisfies the multi-period identity test, and so should be free of chain drift. So the other indexes, well, they deviate from that, and what we're doing here is just changing the length of the window. So we're still using the CCDI index with the mean splice. What we're changing is the window length. So we're constructing an initial window and then we're rolling it forward. So how many months should that initial window and subsequent windows cover? Well, we consider a sub-year period of 7 months, and that is this one here, and obviously it looks like we've got a huge amount of chain drift, even though we're using a multilateral index.
So while we're waiting, I suppose I can have a crack at some of the questions in the Q&A box that have accumulated. Well, I'm sure Kevin, when he comes back, will be able to give better answers than I'll be able to. So starting off with, I'll start off with Martin Wheel's questions. So he asks, how can the choice of different approaches be informed by assumptions about underlying utility functions? So I think this is very interesting. So certainly with bilateral indices, we know that there's cost of living justification for some indices rather than others. So we know that Euler spares is going to be associated with Leontief preferences. We know that the Turnquist has desirable properties when it comes to approximating the cost of living function for homothetic utility functions. So I suppose the logic extends reasonably well to the multilateral case, in the sense that it's a weighted average of these bilateral comparisons. I suppose the sort of analogy breaks down at a certain point, because once you've gone into a multilateral index and you're comparing periods where the products are different, and that's indeed one of the reasons why you get chain drift in the first place. And then at that point you have to worry about missing goods, for example, and the effect that they would have on people's welfare. I think at that stage you have to worry about the way you impute prices, and is there a way to impute prices in a way that's consistent with different utility functions. I know that that's something Kevin's done a lot of work doing. Simple question from Suzanne Ellis: will slides be available post-presentation? Yes, I'm sure we will be able to provide those. Usman asks, can the GEX be paired with any bilateral index method? Are you aware of any research or analysis on the GEX paired with the bilateral time product dummy or bilateral Giri-Khamis? So as far as I know, the answer to the first question is yes. So it's just a geometric mean of different bilateral comparisons. So I don't see why you couldn't compare that with your favorite bilateral index method. Am I aware of research or analysis using the GEX paired with the bilateral time product dummy? That I'm not aware of. Although one of the advantages of the time product dummy approach is that it can be used to construct multilateral index comparisons as well, as can the Giri-Khamis. So fortunately, it looks like we've got Kevin back. Hi, Kevin.
You'd think after all these 2 years of trying to do Zoom calls, we wouldn't be having these problems at this stage, but my apologies. I'm just going to try and get the screen up. I realise we're getting short of time now. I'm assuming that while I was offline, Peter answered a whole lot of really tough questions.
I did my best. Yeah, so I think if we can try and sort of wrap up the presentation as quickly as possible, and then we can go on to questions.
Yeah, that would be a good idea. So I think I've basically got through most of what I wanted to say, and so just very quickly, I'm going to wrap things up now in the next 3 minutes or so. Okay, so yes, we looked at varying different window lengths, and as you can see, if we shorten the window, we get rather massive chain drift bias. Longer windows, we get less, and so it leads us to recommend 25-month windows. And okay, so we're kind of back now, kind of where I wanted to be. Okay, so yes, we looked at these different comparisons, and chocolate, and then we looked at this is chain drift bias using different window lengths, just looking at the Giri-Khamis with the Giri-Khamis. Let's look at the CCDI with 13 months. So that's CCDI. So all these different splicing methods, each with a 30-month window, and you see it doesn't really matter which method you use, you get very similar results. But you notice with the mean method there's no outliers. So perhaps marginally we prefer the mean splice in that case. Now, switching from this slide to the next one is one of the reasons we come to some of the conclusions we do, because the next slide is the Giri-Khamis, 13-month window and all the different extension methods. And you see there's a lot more difference between the different extension methods, and a lot of outliers. So it seems to be more sensitive than CCDI to the method chosen. Interestingly, the mean splice doesn't look too bad. The half splice doesn't look too bad either. Okay, so we also examine determinants of chain drift bias. So we find that products with high seasonality, monthly and annual churn, there's more chain drift. We also note that Daniel Melser and Michael Webster's paper in 2020, they identified life cycle pricing as a potential source of chain drift bias. And I should add that Daniel Melser was part of our UNSW group when we were working on scanner data with those grants I mentioned earlier. But these problems are mostly solved by the longer window lengths, 25 months or longer. So in summary, mean splice, it compromises over different link periods, and so will not be unlucky in the choice of link period, because it considers them all and averages over them. So mean splice seems to reduce chain drift, and although we don't show it in our results here, you can do a mean splice on the published series as well. And then it doesn't matter if you use the mean splice or the mean splice in the published series. If you really want to do the splicing on the published series, we'll do the mean splice. It has all the advantages that you may perceive about linking on a published series, but you get identical results, essentially, at least in our work, as the regular mean splice. CCDI is used by other agencies, can be decomposed. We can use imputation with CCDI, find strong evidence in favor of using a 25-month window. And we also provide drivers of chain drift and believe this is novel to the literature. So there's more about that in the paper. Of course, there's lots more that can be done. Lots more research. For example, when does a product missingness become a problem? That is, when should you really consider doing some imputation? Does the splicing method depending on the timing of product entry exit? There's a whole other approach to linking which we haven't explored here, and that is similarity linking or dissimilarity linking. This is covered a bit in Dewitt and Fox 2020 in the Journal of Business and Economic Statistics. But Irwin Dewitt has done other approaches than we consider there, including predicted share similarity linking methods, which seem quite promising, but I think more work is needed on those methods to really understand their behavior in different contexts. And there's a lot more work to be done on web scrape data. So I will wrap it up there. And my apologies again for the technical glitch.
Okay, thanks very much, Kevin. That was very interesting. In the interest of time, I'm going to try and group some of these questions by theme, some of the questions that appeared in the Q&A box. Before I do that, during the interval, I was asking a question by Martin Wheel about whether these price indices could be consistent with individual utility functions. And I shamefully forgot to mention Dewitt and Fox, the recent paper that appeared in the Journal of Econometrics, where you simulate cost of living changes for different preferences, and then you see which multilateral index numbers perform best, and the CCDI index performed very well in those simulations at approximating the cost of living index from CES preferences, although it can only be an approximation. But that will be, if one liked the cost of living approach to price indices, that would be another reason to favor the CCDI. So there's a group of questions on high frequency indices. So Andrew Baldwin says, surely most central banks are not interested in month-to-month price comparisons. They're interested in 12-month or 4-month price comparisons. So he uses he uses examples from the Bank of Calendar and Australia, which have quarterly and annual price indexes. And at the same time, there was a question, when you adopt a longer window, do you reduce the volatility of the resulting index? Is there a trade-off for policymakers who may be interested in the high frequency signal from the price index, in addition to the use of a longer run issue of drift and bias? So I guess these are questions of, what's the utility of really high frequency indices, and are there trade-offs when it comes to computing those things?
Excellent questions. First, just to comment on that, Martin's question earlier about the underlying utility functions and preferences. So it was actually in the Journal of Business and Economic Statistics.
Excuse me, yes.
And sorry, just for anyone looking in the Journal of Econometrics for us, in the JBS 2020 online first, has just come out and signed to a 2022 volume recently. So yeah, we looked at the properties of these different methods, and because Gary Khamis and the time product dummy methods are additive methods, what that means is that they do well when elasticity of substitution is very high. It's consistent with elasticity of substitution of infinity. But Gary Khamis is also consistent with Leontief, so zero substitution. So they're rather extremes. The time product dummy is also consistent with Cobb-Douglas preferences, which is a little bit more reasonable. So we don't usually expect consumer preferences or elasticities of substitution to be zero or infinity. And that's why from the economic approach to index numbers, the Gary Khamis is kind of frowned upon because it corresponds with assumptions of very unrealistic consumer behavior that we don't usually observe. But CCDI performs well for elasticities of substitution, which we do see in the data. Okay, so yeah, frequency. So this is a problem with something like the CPI. It's one number which has many purposes. When I chaired the CPI advisory group in Australia back in 2009-10, an issue that came up was the difference between central bankers who wanted more frequent price signals, not quarterly. They wanted monthly CPI, and social welfare groups who didn't really care about month-on-month indexes, and they didn't really care about quarterly indexes either. All they wanted was one accurate measure of inflation each year. So what should we put our resources into? And it's a big question when you're looking at one number and wanting it to do different things for different people. But on the whole, I think it's useful to get more frequent indicators of price signals if you're into the business of managing an economy or even managing your business. Not necessarily managing your investments, but managing your business and knowing what's going on. So I think it's important to have accurate measures of month-to-month indexes, and certainly every time an inflation reading comes out for a month, there's a lot of media attention in it. Australia and New Zealand currently still have quarterly indexes, but maybe not for too much longer. That could be changing finally. So I don't really have much more to say about that, but it is an issue.
Thanks very much. Yes, there's lots of very interesting questions people are asking, and we're not going to have time to get to all of them, I'm afraid. But I just wanted to pick out this question by by Jill Leyland, who asks, since there's huge public interest in CPIs and there's a lot of suspicion about the methodology, as we saw in the UK in the debate about the Jevons and Carley and the RPI, is there a way to explain these methods in the way that ordinary users are going to be able to find easy to understand?
That's interesting. There was a lot of concern in Australia in 2016 when the ABS was thinking about introducing scanner data into the CPI. But when it did in 2017, there was barely a mention of it anywhere in the media. At the same time, they updated the way they reweighted product categories in the CPI, and that got a bit of media attention, but really nothing about the use of scanner data. And so it was quite surprising that the public just seemed to think, well, great, we're using more data in the CPI. Now, the UK has a rather peculiar thing because, that Carley-Jevons business was a complete mess. I mean, and I think back to Irving Fisher's book in 1922, The Making of Index Numbers, where he said if this book serves no other purpose than stopping the use of the Carley index, it will have served a good purpose. And still, Carley is used. So UK faces a rather peculiar situation because of that history. But I think the way to sell it is not to get into the weeds of index number methodology. It's to point out that there's this huge amount of data which is available and that could improve the accuracy of the CPI. And it could also improve things in, say, pandemic conditions. Like the ABS, because it was sourcing so much data electronically, it really didn't, the pandemic really didn't affect its operations. It was only collecting about 2% by expenditure of its CPI basket in the field. And so when they had to stop field collections, it had no real impact. So being able to source data from electronic sources has huge benefits. And so if you just focus on that, you don't need to get into then the index methods that are needed. Just that new data sources are available which can improve the quality of the price indexes that are constructed.
Okay, thanks very much. Yes, sorry, I'm going to pull questions directly from the chat rather than asking people to unmute, just because I want to get to as many of these questions as possible, and I think it's a quicker way of doing things. So there's another set of questions. So we've got a few, like 1 minute. There's a load of questions about missing prices and the way they're implicitly, when goods go missing, they're implicitly downweighted in the comparisons because they're not there in every month, and how well you can impute for those using hedonic imputation and other things. Is it related to seasonally disappearing goods? And is there some way of weighting the bilateral comparisons in the geometric mean in a way that means you don't have, this is less of an issue? So there's a set of questions about kind of missing products and basically how to deal with them.
A very good question, and Jan de Haan and I are going to be looking at this issue about missingness and when you need to take action and what you could possibly do. So currently what agencies seem to do is just ignore the missingness and say they're using CCDI and they're doing a monthly index. You just have to, in each comparison, just doing matching with each bilateral comparison within your GEX framework. And so you're maximizing the overlap. In other words, you've kind of got a flexible basket. It's whatever is there in the two periods being compared is being used. Now, when does it, and that, that's implemented, say, as I understand it, in the Australian CPI. There's no imputation for supermarket products, etc. When prices are missing. But when might it become a problem? Is that right to just ignore it, and is there some way of automating things? I think this is an area that needs more research. So I don't have a definitive answer on this, but it is related to transitory products and product churn more generally, new and disappearing goods. But you know, indexes seem to work just fine if you're doing just ignoring the missingness and linking up. But the problems could emerge if there's a huge amount of churn. As we find in our paper, actually, you know, more churn, more chain drift. Okay,
great. Thank you very much. So apologies to everyone for the technical problems. They're inevitable in this. There are advantages and disadvantages to virtual communication. I hope many of you will be able to join us for the next ESCoE measurement webinar, which will be held in 2 weeks' time. That'll be by Sharada Davidson from the University of Strathclyde, who'll be talking about building a suite of subnational socio-economic indicators for the UK, which sounds very interesting. So I hope many of you will be able to join us in 2 weeks' time. Other than that, it's thank you all for coming, and thank you for Kevin for presenting. And thanks and goodbye.
Thanks very much, Peter. Thanks, everyone.